Right. Today we are going to do a sound paper. You can get the paper in the link. We'll go to the first question. Right. A massless rod of length L is suspended by two identical strings AB. If identical strings mean their length and mass per unit length both are same. Okay. A block of mass M is suspended from point O such that BO is equal to X. If it is observed that the frequency of the first harmonic in the string AB is equal to second harmonic in the string CD, right? First harmonic means there will be one loop, and second harmonic there will be two loops. Just the data is given as the frequencies are same, therefore we can equate the frequencies. F1 is equal to F2. Frequency can be written as velocity over wavelength. Right. It's a proper method. We'll do the shortcut later. Velocity in the string AB is equal to tension in the string over mass per unit length over lambda is equal to one loop is equal to lambda by 2, that is equal to L. Therefore, lambda is equal to 2L. Lambda 1 is equal to 2L. Similarly, two loops. Therefore, 2 times lambda by 2 is equal to L. Therefore, lambda is equal to L. The velocity in the string CD is equal to tension in the string CD over mass per unit length. L and L will be cut off. Root of M and root of M will be cut off. You can square both sides. T1 is equal to 4T2. That means T1 over T2 is equal to 4:1. The tension ratio is inversely proportional to the distance. If the distance is X, the remaining distance is L minus X. Therefore, X over L minus X should be equal to 1:4. If you cross multiply, 4x is equal to L minus X, 5x is equal to L, X is equal to L by 5. This is the proper method. We can do in short also. Right. How to do? V is equal to F lambda. Both frequencies are same. Therefore, V is proportional to lambda. Then, lambda is proportional to L over N. In both instances, L is same. Therefore, lambda is inversely proportional to N. N means number of loops. Right. Then you can combine both of them. V is inversely proportional to number of loops. And you know one more equation. V is equal to root of T O M. As both strings are identical, their M will be same. Therefore, V proportional to root of T. Therefore, finally, root of T is inversely proportional to N. We don't want roots. Therefore, we are going to square both sides. T is proportional to 1 over N squared. That's all. What's the ratio of N? Ratio N is 2 times larger. Right. If N is twice, T will be 1/4. T should be 1/4. For their tension should be in the ratio of 4:1. Their distance should be in the ratio of 1:4. For the tension to be in the ratio of 4:1, their distance should be 1:4. If the distance should be 1:4 means you have to divide total length by 5. If you want to divide the length by 1:4, you have to divide the total length by 4. Therefore, X is equal to L over 5. That's a shortcut. Okay. Question number 2. A uniform thin rope of length 12 meter and mass 6 kilogram. The length is 12 meter, the mass is 6 kilogram. Hangs vertically from a rigid support. And a block of mass 2 kilogram is attached to its frame. Therefore, its weight is 20 Newton. Usually, if the rope is light, the tension will be same along the string. But it has a mass. Therefore, tension in the bottom is not equal to tension in the top. Right. If you find the tension in the bottom, T, for the equilibrium of the bottom block, TB is equal to 20. If you find the tension at the top, it has to hang both 60 Newton and 20 Newton. Therefore, the total tension at the top is equal to 80 Newton. The top portion should withhold the total weight of the rope 60 Newton and the weight of the blocks 20 Newton. Therefore, tension at the top portion is 80 Newton. Then what's the equation? You can do in the proper way. They are asking the wavelength at the bottom and the top. Then you can write the equation V is equal to F lambda 2 times. Velocity at the bottom is equal to frequency into lambda at the bottom. Velocity at the top is equal to the same frequency into wavelength at the top. You can divide 1 by 2. You can substitute. Velocity at the top is bottom is equal to tension at the bottom over mass per unit length. That is equal to F into wavelength at the bottom is equal to given as 6 centimeter into 6 centimeter. Similarly, velocity at the top is equal to tension at the top over mass per unit length. It's equal to F into lambda at the top. If you divide 1 by 2, mm will be cut off, f will be cut off, and TB over TT is equal to 6 centimeter over lambda. You can substitute here. The tension at the bottom is 20, top is 80, that is equal to 6 over lambda. Then 0 and 0 will be cut off. 1 by 4 is in the root. If you take out, half is equal to 6 by lambda. Therefore, lambda is equal to 12 centimeter. This is a proper way. You can do in short way that also. V is equal to F lambda. F is same in the both instance. Therefore, V is proportional to lambda. You know the equation V is equal to root of TOM. M is same because it's a uniform wire. M is same because it's a uniform wire. Therefore, V is proportional to root of T. From the equation V is equal to root of TOM, M is constant throughout the wire. Therefore, V proportional to root of T. You can combine both of them. Lambda is directly proportional to root of T. From bottom to top, tension increases 4 times. Therefore, lambda should increase 2 times. 6 into 2 is equal to 12 centimeters. 6 into 2 is equal to 12 centimeters. That's it. V proportional to lambda, V proportional to root of T. Therefore, lambda is directly proportional to root of T. Tension is quadruple. Therefore, lambda is doubled. Therefore, 6 into 2 is equal to 12 centimeters. Then third question. Third question. A heavy ball of mass capital M is suspended from a ceiling of car by a light string of mass simple m. Simple m is negligible. When a car is at rest, the speed of the transverse wave in the string is equal to 2 root 2 meter per second. When the car has an acceleration a, the wave speed increases to root of 10 ms minus 1. The value of a is closest to. Right. Therefore, in the method 1, the equation V is equal to root of TOM. Here tension is mg, capital Mg when it is at rest, or mass per unit length is symbol m. Right. Here capital M is constant, symbol m is constant. Therefore, you can write V is directly proportional to root of G. Right. Therefore, we don't like roots. Therefore, we can make squared. V squared is proportional to G. At the first instance, the velocity is equal to 2 root 2. If you square it, 8 is directly proportional to G. Now, the velocity is of 10. If you square it, 10 is directly proportional to the resultant acceleration is equal to root of a squared plus g squared. A and g are perpendicular and the resultant is equal to root of a squared plus g squared. If two vectors are perpendicular to each other, you can get the resultant by root of a squared plus b squared. Then if you divide 1 by 2, 4 over 5 is equal to g over root of a squared plus b squared. Still we don't like square roots, therefore we can square both sides. 16 over 25 is equal to g squared over a squared plus g squared. From here you can cross multiply and get answers. Or you can make it reciprocal, a squared plus g squared over g squared is equal to 25 over 16. Then if you subtract the 1, 9 over 16 is equal to a squared over g squared. If you take a root, a over g is equal to 3 over 4. Then a is equal to 3 g by 4. That is the horizontal acceleration of the car. One more method. The method 2 of question number 3. we know V is directly proportional to root of tension from the last question. Here velocity increases by root 5 by 2. Therefore, tension should be increases by 5 by 4. The initial acceleration when it is rest is G. When the car is moving to the right side with an acceleration A, the heavy object inside the car will get an opposite direction of acceleration, that is called pseudo acceleration A. Therefore, resultant acceleration is, as the tension is multiplied by 5 by 4, the resultant acceleration is also multiplied by 5. The tension is, initially tension is equal to mg. Therefore, as the tension is multiplied by 5 by 4, the resultant acceleration also multiplied by 5. You know F is proportional to A. As the resultant force is multiplied by 5 by 4, acceleration also multiplied by 5 by 4. Therefore, resultant acceleration is equal to 5g by 4. The resultant of A and G is equal to 5g by 4 means A squared plus G squared is equal to 5g by 4 whole thing squared. By removing the bracket and squared, you can get A squared is equal to 9g squared by 16. A is equal to 3g by 4. This is one of the shortcuts. Another method. This is G. This is acceleration A. You can mark the angle of inclination with the vertical as G. You know the resultant acceleration is equal to 5g by 4. Therefore, you can write cos theta is equal to g over 5g by 4. That means 4 over 5. If you know the cos theta is equal to 4 over 5, you can get tan theta is equal to 3 over 4. Theta, adjacent side is 4, hypotenuse is 5 means automatically according to Pythagoras theorem, opposite side will be 3. Therefore, tan theta is equal to 3 over 4, that is equal to opposite is A here, adjacent is G. Therefore, A is equal to 3g by 4. Therefore, this is the third method. You can use either one of it. Question number 4. It is our practical 14 in our syllabus. The initial length is L1. When a pipe closed at one end, it's made to vibrate by a tuning fork. A resonance is heard at the length of L1. Again, the resonance heard at the length of L2. From this, we can find the wavelength. One loop is equal to lambda by 2. Therefore, half a loop is equal to lambda by 4. That is equal to not only L1 plus an end correction E. That means the air molecules not vibrate within the pipe. Some portion of air molecules are vibrating outside the pipe also. That is called as end correction. Right. Therefore, in the second case, there are 1.5 loops. One loop is equal to lambda by 2. Therefore, this is lambda. Half a loop is equal to lambda by 4. Lambda by 4, lambda by 4. 3 times lambda by 4 is there. That is equal to L2 plus C. If you subtract the first equation from the second one, you will get lambda by 2 is equal to L2 minus L1. You can understand something. When you are subtracting 1 and 2, the E and E will be cancelled out. The same technique we are using in the spirometer, right? Subtracting 2 readings, the errors will be cancelled out, right? Therefore, lambda by 2 is equal to L2 minus L1. Therefore, lambda is equal to 2 times L2 minus L1. Therefore, directly it's a practical output. Answer is third one. And you must know, in both tubes, end corrections are same because the end corrections depends on the size of the diameter. That is roughly 0.3 times of diameter, or you can say roughly 0.6 times of the radius of the tube. Therefore, it doesn't depend on the length. It depends on the diameter. Both instances, the diameters are same. Therefore, their end corrections will be same. Question number 5. When a tuning fork of 250 Hz frequency is sounded together with another tuning fork, it gives 3 beats per second. Right. You can use a number line to do this question. The frequency of the first tuning fork is 250 Hz. If the second tuning fork is giving 3 beats, mean it can be plus 3 Hz or minus 3 Hz. That means the second tuning fork may be of 253 Hz or 247 Hz, right? And if the prong of the first tuning fork is rubbed slightly, what are the theories related to this? Tuning fork, if the tuning fork is rubbed, its frequency will be increased. If you add some wax, the frequency will be decreased. And one more thing, if you increase the temperature also, frequency will be decreased. These are the theories you should know. Therefore, if you are rubbing this one, its frequency is increasing. If the initial tuning fork, if the second tuning fork is 247, the gap is increasing. If the second tuning fork is 253, the gap is decreasing. In the question, it is mentioned that the beats are decreasing. Therefore, the frequency of the second one should be 253. That's why the gap is decreasing. Therefore, answer is 253. For example, if they ask if the frequency, the beat frequency is increasing, means the answer will be 247. Therefore, question number 5, answer number 4. They can ask one more question. They can ask a new frequency of the first tuning fork. Now the gap is 1. Therefore, new frequency will be 252 Hz. Right. In the question number 6, the displacement graph is given. You must know one thing. The displacement graph is opposite to pressure variation graph. If a point is a displacement antinode, mean the particle at the antinode is vibrating at a maximum amplitude. At the point, the pressure fluctuation will be 0. At the displacement antinode, the pressure the fluctuation will be 0. Therefore, it will be denoted by pressure node. At the same time, these particles cannot move. That means there is a displacement node. At the point, the pressure variation is maximum. Therefore, we have to mark it by pressure antinode. Therefore, what's the theory? At the displacement antinode, pressure will be node. At the same time, displacement node, pressure will be antinode. Therefore, the pressure fluctuation will be opposite to displacement. Therefore, at the point P, it is displacement antinode. Therefore, obviously, this is a pressure node. Therefore, the pressure variation at the point P is 0. And in the pipe, the particles are vibrating along the direction, axial direction, parallel to the axis, not perpendicular. But we are denoting in a picture in a perpendicular manner to denote that maximum, it has a maximum amplitude and it has a minimum amplitude. But actually, the particles are vibrating not perpendicularly, they are vibrating along the axis. To denote the maximum amplitude only we are using this picture, but in real, the particles are vibrating, they are longitudinal wave, they are vibrating along the length, not perpendicular to the length. Therefore, the best answer for the question number 6 is second one. Question number 7. The ratio of loops formed in a sonometer wire when the weight suspended from its end is immersed fully in water and liquid respectively is 2:3. In sonometer wire, it is attached to a weight and weight is immersed in a liquid. Right. The relative density of the weight is 2. They are asking the relative density of the liquid. That's the question, no? It's a V is equal to F lambda while the wire is vibrated by a source. From that word, you can get a source means for one source, frequency will be same. Then V proportional to lambda. And you know, V is equal to velocity of transverse wave in stretch string is equal to root of TOM. Same string, therefore M will be constant. Therefore, V is directly proportional to the tension. And lambda is directly proportional to length and inversely proportional to number of loops. Here length is same. Therefore, lambda is inversely proportional to n. If you combine all of them, V is proportional to lambda, lambda inversely proportional to n, V proportional to root of t, then you can get root of tension is inversely proportional to number of loops. It's difficult to do in roots, therefore we make it square. T proportional to 1 over n square. Therefore, initial tension T1 over final tension T2 is equal to reciprocal of n square. 9 by 4. N ratio is 2:3 Therefore, reciprocal is 9:4. Now, initially the density of an object of relative density 2 is immersed in the relative density of 1 water. Therefore, net relative density is equal to 1. Now, the same object, relative density of 2, is inserted in a liquid of relative density of S. Therefore, if it is subtracted, that will be 2 minus S. We'll do in a proper way. That's, you can directly put if you can, right? If you cross multiply, you can get the answer of S is equal to 14/9. If you cross multiply, you can get the answer S is equal to 14/9. That is roughly 1.555. If you approximate, then 1.56 will be the answer. If you are unable to put this directly, you can write and get the apparent weight equation what we studied in grade 11. Right? When an object is immersed in a liquid, its tension is equal to weight minus upthrust. The first tension, T1, let the object, volume of the object is V. Density of the object is rho water into 2. We have to multiply the relative density by the density of water to get the density. And gravity is G. The upthrust is water, is given by water. Therefore, V rho water G. Second one, when the same object is inserted in a liquid of relative density S, the weight is same. V rho water into 2 G. Upthrust is V rho water into S now into G. If you divide 1 by 2, T1 over T2 will be equal. VV will be cut off, rho water cut off, G will be cut off. 2 minus 1 over 2 minus S. That's what we directly put. If you can, with practice, you can get it. Therefore, question number 7, answer number 4. Question number 8. The length of a sonometer wire under tension is 80 centimeter. For a sonometer wire, the mass per unit length will be same. And a knife edge is placed at the middle of the sonometer wire without affecting the tension. The knife edge is dividing the wire into two portions, but the tensions are still same. Therefore, velocity only depends on tension and the mass per unit length. If both are constant, velocity will remains unchanged. By the knife edge, the wire has been divided into two parts. The vibrating lengths are 39.5 centimeter and 40.5 centimeter. And 10 beats per second were heard when these two parts of the wire were vibrated simultaneously. The vibration frequencies of each part, right? V is equal to F lambda. We got V is equal to same. Therefore, F is inversely proportional to lambda. Lambda is directly proportional to L. Therefore, F is inversely proportional to L. You must know, according to this equation, the larger length will have the lowest frequency. Therefore, if you take the frequency that the second wire is F, the first one will be F plus 10. The shorter wire has a larger frequency. Therefore, beat should be 10 Hz. Therefore, this should, if it is 10, if it is F, this should be F plus 10. Or other way around. If it is F, that should be F minus 10. The beat frequencies are 10 and the shorter wire should have the highest frequency. Therefore, if you take the largest length as F, the shortest length have F plus 10. You can use this equation 2 times and you can get the answer. F plus 10 is inversely proportional to 39.5. F is inversely proportional to 40.5. If you divide F plus 10 over F is equal to A over B over C over D. The fourth one will go up 40.5 over 39.5. You can cross multiply and get the answer, or you can use the DC method. Keep the F itself and 39.5 will be remain. You can subtract 2 minus from 1, then 10 will be remaining. The same thing you have to do. If you subtract the second one from the first one, 1 will remain. Then F is equal to 39.5 into 10 is equal to 395 Hz. Therefore, F plus 10 is equal to 405 Hz. Therefore, the answer is third one. So, you can do in the equation method. you can write F1 is equal to velocity over wavelength. Wavelength is equal to 2 into 39.5. Similarly, you can write F2 is equal to V over 2 into 40.5. You can subtract and write the equation F1 minus F4, the BT equation, that is equal to 10. BT is equal to the difference of the frequencies. Right. Then you can substitute F1 V over 2 into 39.5. F2 is equal to V over 2 into 40.5. That is equal to 10. From this, you can take LCM and calculate V. V is equal to 2 into 39.5 into 40.5 into 10. Then F1, you can use this equation to get F1. F1 is equal to V over 2 into 39.5. From this equation, if you substitute V, you can get F is equal to 405 Hz. From this equation, you can get F is equal to 405 Hz. Therefore, F2 is equal to 305 Hz. But here we are wasting time in finding V. No need to find V. You can directly use the equation. Or properly you can do like this. Or in another short way, you can use F plus 10 over F is equal to 40.5 over 39.5. You can write this as 39.5 plus 1 over 39.5 is equal to F plus 10 over F. Here, the 1 is multiplied by 10. Therefore, this should be also multiplied by 10 to maintain the same factor. This denominator should be also multiplied by 10. Therefore, F should be 395. For example, if it is 2, if it is 10, this is multiplied by 5. Therefore, F should be also multiplied by 5. Similarly, therefore, if 1 is multiplied by 10, therefore 39.5 should be also multiplied by 10. Answer is 395. There are 3 methods. You can use one of these to get the answers. Question number 9. Question number 9 is the application of the practical 14 as we see in question number 4. The same. Initially, a resonance occurred for a tuning fork of 480 Hz at a length of 30 cm. The second time resonance occurred, this is fundamental mode of vibration, this is first overtone. Therefore, lambda by 4 is equal to 30 plus E. Here 3 lambda by 4 is equal to 70 plus E. It's given as 70. Therefore, if you subtract 1 from 2, lambda by 2 is equal to 40 centimeter. Why we are subtracting? To eliminate E from the both equation. Therefore, lambda is equal to 80 centimeter. The question is the velocity, no? Then V is equal to F lambda. We are going to find F480. When we subtract, we have to put in the SH unit. Therefore, 80 centimeter means 80 over 100 meter. 0, 0 cut off, 0, 0 cut off. And 8 into 8, 64. There is only one answer, that is the last digit is 4, that is fourth one. And if you multiply, and you can get the answer 384 Hz. Here we have to check in both instances. Okay, the answer is 384. Lambdas are same in both instances because velocity is same in both instances. In both instances, the vibrating frequency is same. Therefore, lambdas are same. Therefore, you can use this. You can directly use lambda is equal to 2 times L2 minus L1. And you can get the lambda. And if you multiply F and lambda, you can get the velocity. This is a practical way of finding velocities or wavelength. Let's consider the fundamental mode of vibration. That means at the open space, there will be antinode. In the middle, there will be node. Therefore, completely they form a one loop. One loop is equal to lambda by 2. Right. Then we can calculate the lambda from the equations V and F. V is 340. F is 680. Therefore, lambda is equal to half meter. That means 500 mm. Here, lambda by 2 is equal to L. L is equal to Here lambda is 500 mm. From this equation we can get lambda is L is equal to 250 mm. Therefore answer B is possible. Length 250 mm can made to vibrate at the fundamental mode. Right. Let's check the required length for the first overtone. In the first overtone, this is fundamental. In the first overtone, always in the open space there will be a antinode and the extra node will be formed. Right. Altogether they will complete 2 loops. 2 loops is equal to 1 lambda, that is equal to L. We already calculated 1 lambda is equal to 500. Therefore L can be 500 mm also. Therefore answer C also possible. At first overtone it can occur. That means 250 mm is possible, 500 mm is possible. This is the least length. Therefore hereafter length is going to increase. Therefore 125 mm will never form in this pipe or open at both ends. Therefore we can make a pattern. We can check for the second overtone. In second overtone, in always in the open space there will be a antinode. An extra 1 loop is there. Therefore there are 3 complete loops. 1 loop is equal to lambda by 2, that is equal to L. Therefore L is equal to 3 by 2 times 500, that is 750 mm. I think now you got an pattern. 250, 500, 750, 1000, 1250 can be possible. Which is impossible? Any length less than 125 is impossible. Therefore answers are B and C possible. 5th answer.